A to the fifth, a to the fourth, a cubed, a squared, a. I got b to the fifth. Now, if I have b to the fifth on the last term, how can I fill in for the b's? Help me out. Let's go backwards. What should the previous term have? B to the fourth. Then b cubed, b squared, b. And a quick check if we have all this correct here. Let's see, an exponent of 5 here. I have two exponents that would sum up to a 5. 3 plus 2, 5. 2 plus 3, 5. And this could be a 1. 1 plus 4 is 5. Of course, the last one's a 5. So that looks pretty good. Now, where are the coefficients? What were we doing yesterday to find where those coefficients are located and bring them over and put them in? Where are they? I think we were using the triangle yesterday, weren't we? Remind me, please, this point. Was the tip of the triangle representing a plus b raised to the 0? The second row here, is a plus b raised to the first. This set of coefficients were a plus b squared. And this set of coefficients, a plus b cubed. And here I got a plus b raised to the 4th. Do we agree at this point? Are those the coefficients I have written so far? Corresponding with the a plus b? Yes or no? Now, see, mine is a plus b raised to the 5th, so I need another layer. And guys, the other layer will be, and I'll put this in red, definitely it's going to be a 1 on the ends. Now, who recalls how to get the intervening numbers in that row? What do we do? Even from middle school. Do you want to recall how to get the next layer? If we go back to the previous layer, do something with it, like 1 plus 4 gives me a 5, 4 plus 6 gives me a 10, 6 plus 4 gives me a 10, 4 plus 1 gives me a 5, and of course it ends with a 1. Is that true? And if I pull those numbers out of red, take them over, then it looks like, if there's no mistake, and I get all these squeezed in, it looks like that. And again, we point out for a reason, this in the red, those coefficients represent a plus b raised to the 5th. And basically, I think that's what we ended with doing yesterday to expand a binomial. Is it true? Now, did I not prompt you a new way to rewrite this? And you try to make some connections and finally end up with what on earth is this? If I hear the word theorem, I expect some type of statement. And usually if you have a theorem, they ask you to prove it. Is that true? So we're not going to try to prove this one. But I am going to show you what it looks like. Okay, at this point, let's make some connections if we can, if I get all my alignments correct here. Okay, here goes. I'm going to rename, I'm going to put right next to it, the tip of the triangle is now 1. For the purposes of where I'm going, I need to rename that as 0, choose 0. In fact, I should put it over here so we can see it. This is now going to be the tip of the triangle. The first thing you're going to see a pattern come out. And I'll remind you what n choose j was from yesterday. Guys, the next set of coefficients, 1, 1, I'm going to write that as 1, choose 0, 1, choose 1. Or another triangle, different notation. 1, 2, 1, it's going to be represented as 2, choose 0, 2, choose 1, 2, choose 2. So I've got a triangle going on here. The 1, 3, 3, 1 for the a plus b cubed, where 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. And I could continue. Now, does that look strange? That sort of looks strange, doesn't it? But I still formed a triangle. Now, can anyone tell me, and then I'll remind you what the n choose j was. Anyone tell me, what do you think 0 choose 0 might give me if I even reflect back to that formula? What might that give me? Is that going to correspond with the 1, which was right here to begin with? Now on the side here, can anyone remind me what was, in case I need it, n choose j? That was like a formula. Now I think there was a factorial involved. Does anyone recall what it looked like? Go for it, Philip.
Yeah, I think it was n factorial
N factorial.
over j factorial
J factorial.
times n minus j factorial.
N minus j factorial. So if we should apply this, if I accept this formula, to 0, choose 0, students are telling me you're going to get a 1, which now corresponds with the tip of the triangle in the Pascal's triangle. I hope we do get a 1. Guys, we're going to do it real quickly here on the side. Is 0 choose 0? Which to me as a student would be 0, I would think. But if I use the formula, it's 0 factorial, n minus j, 0 subtract 0, another 0 factorial. And what are we supposed to accept 0 factorial as representing? By definition, 1. So I have a string of 1s here. What, that's 1 times 1, of course we get 1. That agrees with what we thought right here. Now, just to make sure, we're going further. Let me jump down to this layer here. In Pascal's triangle, written a little differently. Guys, let me go to the 1, 2, 3, 4. Let me try this term here. This one. Let's try 3 choose 2. Just out of curiosity. By using the formula. It's going to be 3 factorial over 2 factorial, and then n minus j, 3 subtract 2, 1 factorial. Guys, if all that's correct, you got 3 times 2 times 1, that's what factorial means. Then down here, 2 times 1, and of course there's 1 here. And to do some canceling here right quickly, I think after all that thought, is this right here representing 3? When I do all the calculations. Now, if I look back at Pascal's triangle for middle school, guys, this was for, I'm going to try to find it in Pascal's triangle. Was it for this term right here? Which was 3 for middle school. Now it's also 3 for us in this notation. Now, there must be a pattern there. There's something going on within that triangle, especially written like this. And then I'll write down what that conclusion is, and we'll call it the theorem when we finally see a conclusion. Now, I will tell you the theorem will contain that, which for us means what? Summation, which means what? We should be summing. If you see all these little plus signs and these expansions, are we actually adding? So there's a summation going on. So there's a summation going on in my theorem or statement. And I'm going to get you started. That's for you to help me. At the base of this sigma, here goes, guys. I'm going to start with j is equal to 0. Do I have some j's to work with over here? N choose j. Each one of those is in the form of n choose j. So we'll start with j is equal to 0 at the base and go through n. Now, someone's going to have to help me here. And then I'm going to get some room here. Guys, look back at the way we're renaming right here. Renaming Pascal's triangle based on the middle school. These are the results from middle school. These are the results from this, with the help of the binomial theorem coming up. There must be some type of connection for me. Now, what type of connection is there? Does anyone see a pattern at all? Something going on. If I've got a plus b raised to the 0, right here, which is 1, which is this right here at the tip of the triangle, is there also a 0 here on the top of that n choose j? Is that what n's representing? The next one has a 1 for the exponent, a plus b raised to the first. Was there, sure enough, if I look back, was there a 1 at the top here? A plus B squared, of course, gave me this. I see the exponent is a 2. Now look back at the layer that corresponds with that. I see all these 2's all the way across. A plus B cubed, just I have it written there for you. I see a 3 there for the exponent, and was there 3, 3, 3, 3, all the way across. Now, with that little observation, can anyone tell me what the next layer might look like? At least give me something. What should the top be for the next layer?
4.
I would expect a 4 all the way across. Now, how many of those? I got 1, 2, 3, 4. How many of these will I have all together? Would it be 5? Okay, so I got 4 here, 4 here, all the way across, 4 here, 4 here, and out here, 4. Just like it happened over here. Now the bottom number, the J. Back here, let me find where I am. Let's try, guys. The bottom number here was, let's try this layer here. 0, 1, 2. 0, 1, 2, 3. What might my bottom numbers be here? Is there a pattern there? Can I just fill in the numbers right now based on the other layers? Can I put a 0 here? Looks like a 0 is underneath all the others. Can I start with a 0 here? Can I now pick up a 1 like the others had? Next. Then maybe 2, 3, and finally 4. That's the next layer. Done for me. What else should I point out? Well, let's see what else is there. Oh yes, here we go. Now the A to the 5th, in this case it's A to the 5th. Help me if. At this point, looks like this is going to be an A plus B raised to the 4th for this example. Tell me what you think A is being raised to here. And here. Let's get the A's out of the way. Here, here, and finally here. What should A be raised to in that first term? Should it be 4? That's your guys? For A plus B raised to the 4th? I would think the next should be what? If it's in descending order, Q squared 1. Now, is there something going on within this notation that tells me also those exponents should be what I just placed? I notice this first term, we're having A to the 4th, which comes, it says it should be A to the 4th. Is that also, that 4, is that the difference of these two numbers? 4 subtract 0. So that can be 4. Next one, I know it's A cubed, you know it's A cubed. But is it also the difference of these two numbers in that term 4 subtract 1? And this one's 4 subtract 2 gives me the exponent for the A. 4 subtract 3 gives me the exponent for the A, so forth and so on. Now the B coming in. If I place the B, it shows up in the second term. And here, and we'll put the exponents on it. And here, squeeze that in, and here. So we got on that in there, so that A be raised to 0 if I want to keep it. Now the B's. What are the exponents for the B's? And is there something I can just look at to see what they are right quickly? What are the exponents for the B as I go through it? Is that just the bottom number? The A had for an exponent the difference. 4 subtract 1 give me a 3 for the A. The B though, I'm expecting right here maybe what? B to the 1st? Is that the bottom, just the bottom number of that N choose J. Next one I was expecting a square here, bottom number. Next one a cube, just look at the bottom number. And here of course 4. And I can quickly just fill that in with that pattern there. That's done. This little pattern here, little notation going on, so forth and so on. Now, when I write all this out though, this is what the textbook does for you. They did not show you all this in the textbook. they're saying all this can be written, if you wish, and they call it a theorem, like this. I'll make sure that I get the notations they were using right here. They're saying, just write it like this. We've got an N choose J coming in. And they have this, A plus B raised to the N is equal to, let's stick with the blue there, the sigma. And they have the sigma written in this form, and see if you guys will agree. They want to start at 0 at the base up through N. N choose J is going on. A raised to the N minus J. B raised to the J. And they're saying all this represents a binomial being raised to a power. N. And guys, they classify this as a binomial theorem. In essence, is that what we were discussing over here? Looks a little different, looks a little strange, where they express that as the binomial theorem. Aiden, I'm not going to try to prove it. I have a nice, sometimes I pass out a proof for this, and we did the proof by math induction in one class. And it took forever to show that this statement is true for all positive integers. Guys, what I want for this class is to look at this. Does it fall in line with our discussion here? With the A being raised to a power, B being raised to a power, and then the N choose J, help me out to find the coefficients. Is that making sense? So A plus B raised to the N. Who on earth in middle school will not see this? It's written like this. It's a sum, plus signs, N choose J, and so forth and so on. And that will be the binomial theorem. Now, with that said, some instructors don't do this, but I think it's fun to do if we accept this. A lot of instructors are happy just for students to accept this, but it looks so strange. I did this though, before I jump into everything here. Just one second, let's make sure I got the nice one here. I do. Here we go. On the side, suppose you're asked this. Find the 7th term in the expansion of, I'll just write what I want to expand here, in the expansion of this binomial. 2x plus 3 raised to the 9th. Or about if I should expand this thing out 10 terms. Should be 10 terms. Could I go through and do that? Of course I could. Maybe a little time consuming. I could write out all 10 terms. And then make use of all this that we discussed here, fill in all the parts I need of those 10 terms, and then count down to the 7th term and say, Professor, there it is. That's the 7th term. I want someone to look at what we're doing. Can someone see a clever way so I need not write all those terms out down to the 7th, which might be a little time consuming, and maybe find it quickly by using something else. And before you come up with it, just out of curiosity, let me do this. I'm going to write out the first 3 terms of the 10 terms with your help. Let's get the maybe N choose J. Guys, this term would contain what in the N choose J notation? The way it looks. What would you place on that first term if I want to make it look more like our discussion over here as we did it? What should I place here for that first term in this expansion? Is it 9 choose 0? Yes or no? I know that. If it's 9 choose 0 there, it must be 9 choose 1 here. easily done. 9 choose 2 here, and of course it continues. I'm just write the first 3 terms. Jonathan, after I get those 9 choose 0, 9 choose 1, 9 choose 2, the other parts will be easy. Because the binomial theorem says now, your next part is merely raised to the n minus j. So that means in my first term, I'm going to have my 2x being raised to what? 2 minus 0. Absolutely, 2. Let me get this one out of the way. 2x, my first term, in this term will be raised to the what? 8. And down here, 2x being raised to the 7. Is that true? Yes, no? Are we subtracting right here? 9 subtract 0, 9 subtract 1, 9 subtract 2 for the first term? What's it now?
Yeah, exponent's 9, not 2.
Where was it? 9, where?
The first term.
Oh, yeah, right here. That's all. Everything else good? Now the B, 3. What happens to the 3? And when does it show up? That's my B, acting as a B, that's my 3. Was it supposed to be showing up in the first term, or does it start showing up in the second term? So I'm gonna squeeze that in, guys. That's what I'm concerned about, trying to squeeze all this in for you. Let me erase this. Spread this out a little bit. Should this contain just B, or a 3? And next would be, and I erased it, I think we said it's what, 9 choose 2, was it? 2x raised to the 7th, I think it was, I erased it. And 3 what here? 3 what? Squared? And I can write the other terms out the same way. I'm not gonna write out all 10 terms. Would you guys agree with the first 3 terms? Are they expressed now correctly? Woo, I like that line here. Now, 1, 2, 3, I wrote out the first 3. They're asking me though to find the 7th. It's down here. Which may take a little time, but it can be done. If you have time, go on down to this routine called binomial theorem. Go down to the 7th term. Might there be something going on there, though, where I can find the value of the 7th term without going through all that? Where's an idea? I just want to know what the 7th term might look like. And I'll just start out with maybe 9 choose something. What might it be by the time I reach the 7th term?
The bottom part is
The bottom part, yeah. How much?
It's 1 less than the term that you're trying to find.
So you're saying this is 9 choose 6? You guys agree? Let's see. Now if it is, I have the other parts pretty much in place here. If it is 9 choose 6, we're going to ask you why it shows a 6 there. If it's 6, then the next term should be what? 2x raised to the 3rd, is it? And 3 raised to the what? 6. He's telling me he thinks the 7th term, if I should go on down, might look like that. You guys agree? If I take a close look at it here, guys, the 2nd term, there's a 1 here, underneath. 3rd term, there's a 2. So if I'm asking for the 7th term, he's telling me by observation, Professor, maybe it should be 6 out here. If you're looking for the 7th term, this was the first term, this is the 9 choose 1, 9 choose 0, 9 choose 1, 9 choose 2. Do you guys agree there should be a 6 beneath that if there's a pattern there? Or if there's a change? Who agrees? Or who might see something else? Or are we to accept that this might express the 7th term? Okay, first term on 9. First term, the number is what? 0. 2nd term, what? 1 was there. 3rd term is what? 2. So he's telling me whatever term it is, the bottom number should be what? 1 less. So I'm looking for the 7th term. He says for the 6th, Professor. So 9 choose 6 should be the coefficient. Then 2x cubed is n subtract j by that formula. So you're going to get a 3. 9 subtract 6. And then 3 raised to that bottom number 6. Wow. Nima, you agree? with that? Now, we could calculate this and see what that large number is and coefficient is and so forth and so on. Mr. Park, I may need you here if I actually want to see what that term really looks like. But I think the class is saying, yes, Professor, I think that's the routine or the pattern here to find the seventh term. Okay, here goes. 9 choose 6, 9 factorial, over 6 factorial, over 9 subtract 6, 3 factorial. Now I'm going to go ahead and calculate and see what that might look like. Guys, I'm doing a little canceling here, now we can express all the factorials out, is that true? 9 times 8 times 7, 6, 5, 4, 3, 2, 1. Some of you guys can see a shortcut doing this. On the bottom there, 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. And of course, 3 factorial, 3 times 2 times 1. If you want to do it like that, then do lots of canceling. And if I do lots of canceling, all this is going to mark out. Guys, the other mess is a mess. But here goes, I'll do the best I can here. 6's will cancel. 5's will cancel. I'm right on top of the board here with that glare. 4 will cancel. I can cancel 3 into 9 to get a 3. Now watch my arithmetic here. 2 into 8, you get a 4. And if that's right, that's 3 times 4 is 12 times 7, 84? Okay, I did it fairly quickly there. So it's 84 for 9 choose 6. Then I've got what? 2x cubed, which will give me an 8x cubed. And 3 to the 6, remind me what is 3 to the 6? 729? 3 to the 6? Is it 729? Yes? No?
Yeah.
Mr. Park, I brought this in at the last moment. I knew I was going to get some crazy big number for a coefficient. Am I going to get a crazy big number if all of those numbers are correct up there? Mr. Park, just up since I brought it in, help us out. Do you guys read the numbers you see right now? Okay, Mr. Park, multiply 84 times 8 times 729 and tell us what on earth is that?
48, 98,
Oh, 48?
it's
48,000?
48,000.
Okay.
It's actually,
That was the actual 48,000, how much?
it's 480K, but it's 48, 98, 88.
Wait, 48,
98,
98,
98,
hold on. Are you telling us this?
88, yeah,
That?
yeah.
489,898? Jeez, hang on. Found the 7th term, and that's the coefficient? Is that large? You guys agree with the numbers before he did that for me? Is that true? Did you guys agree with the numbers that we were dealing with to get to that point? Barbara, did you agree with those numbers? Did you agree with those numbers? Yeah. But Mr. Park, now he did the arithmetic for you. He says there's that big number there. Adrian, 489,898, and I was trying to be careful when I placed all this up here. And I'm asking for the 7th term in that expansion. And we're saying, well, at least that much is that. Right? Am I finished? Oh my goodness, what else do we have to do here? Have we done this yet? Have we done this part here, 2x cubed? Have we done this? Or did we? Did we leave 3 to the 6? Did we do all that somewhere on the side here and do all that business or not? Is that the final coefficient?
Without
Yeah, but we got the, x in this case, right? On the seventh term, we got an x there, and it looks like the x might be x to the what here? Where was it written down here? X cubed? You guys agree? Wow. Now, I see why some instructors stay away from this. They'll say, oh, for goodness sakes, don't ask them to find a particular term. Because look what a large coefficient I have here, if that coefficient is correct. Right? A huge, huge number there. Jonathan, all it comes down to is, I want you guys to be able to, if you can, expand by taking knowledge, having knowledge of this binomial theorem. Okay, I'm not going to scare you with a big number like this on a final exam. You can't do that.
What did we find over there with the 3 and the 4? 12. Like what
This was the 9 choose, what was it, 9 choose 6? Was it 9 choose 6? And did we do all this business here? We got what, 84? Right, and then this 2x being cubed gave me an 8x cubed, I wasn't quite finished. And then this 3 to the 6, I think someone's going to be, what, 729? Then you have to multiply all these numbers together, and Mr. Park says it's that. That's the coefficient of that seventh term. Ah. Can you imagine after the final exam on Friday, you go outside and you talk to your friends after the final exam is over, if you have enough energy left to talk to someone after that final, because you're going to be drained, I'm going to be drained, and you say, what did you get for that, Randy? Asked us to find the seventh term. I don't know how many students out in the hallway are going to say, I got 489,898. But that's what it looks like it is. Okay, guys, that's what I want to point out. By the way, I hope this helped by looking at this from middle school into this and finally making some, have knowledge of this, which they call the binomial theorem. That's all it comes down to. Make use of the binomial theorem. Yes?
What would be a typical question that we would be asking?
Do it right now. We're going to do it right now. After all this, I'll show you what's going to happen. I would not ask you, I'm not going to ask you to find a particular term. It takes forever. It might be some big number like this one was. Jonathan, here we go. Good question. I have brought in this. Here we go. First, to start out, I'm going to do this. I'm going to have on the board 1 plus 5 plus 9, so forth and so on, up to 73. That's a sum. I bet we sum those up. First term is 1. Last term is 73, and I give you a few intervening terms. First, Jonathan, good question. You will be asked, can you rewrite this using the summation, which is a sum? Which means I want you to start with this and go through something and fill it out for me and show me that that sum can be expressed in this sigma notation. Now I need some input from you guys. It's a summation, so it should be expressed with a sigma. I see plus signs up there. Help me out. What do you think would help? Because I see things missing right now. I don't have a number on top yet. I don't have anything out here to work with. Any ideas? Wow.
N equals 73.
The big end.
N equals 73.
Add 73
That's the N.
at the end.
Yeah. So that's the number that goes on top.
Okay, so we think maybe 73 goes on top. That's why I brought this in. Now again, I know exactly why you think that. You say that's the last term, Professor. So 73 should go on top. Something else. Now see why he said that. Or by.
So 19?
Whoa, 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 whoa. That's a big contrast between 73 and 19. He's saying, Professor, place a 19 up there. You're going to tell me what you're thinking, and I'll tell you how to find it maybe. What were you thinking?
It's 4j minus 3. Oh, if j is 1, actually, I started by 1.
Oh, you started at 1, you're supposed to start at 0.
By 0 would be 20, would be 19.
Okay, but so I want you to rewrite this using this form if we can. Okay, but, okay, you're saying you want to start with 1, like we were yesterday. Hang on. No problem. If you want that there, and if you want to look more like what we were doing yesterday, I got you. You can say, Professor, can I use K? I think we either used a K or an N. Start with 1. Okay, no problem. Now what?
In that form, should you write it in that form?
We eventually will, but I think you want me to do n's equal to 1 and make it look more like what we were discussing yesterday, which it can be done. Missing, guys, is inside here. Who has an idea what? It's like a little formula that I need to place inside there. So when I start replacing n by 1, n by 2, n by 3, you get those terms you see up there. And Farbod tells me the last number I'll be plugging into that formula when you get it to me is 19. Who has an idea what that formula might be? And sometimes it's patterns here. The numbers you see here, guys, I see a 1, jumps to a 5, jumps to a 9. Looks like there's a 4 involved.
N plus 4.
Here we go.
N plus 4.
Okay, hang on now. Right with you. N plus 4. Now I will stick with his beginning of n is equal to 1. When I put a 1 into this, I get 1 plus 4 is 5, when actually the first term was 1. And I need to adjust that. Not n plus 5. Does anyone see? I do see there's somehow a 4 involved because I see a difference of 4. Does anyone see maybe a formula? And sometimes that's the hardest part, trying to come up with a formula. Great.
Is it 4n plus 1? Also, I think it's 18, not 19, by the equation.
Oh, you want an 18 at the top.
If it's 4n plus 1.
Okay, got you. Great. Hang on. Ray says, Professor, try 4n plus 1. Now, if you had 4n plus 1, did you want to stick with the base to be a 1? Because if I put a 1 in there, I got you. She says, Professor, put a 0 in there, and what she's thinking. If I put a 0 in there, I'll get a 1. That's the first term. Ray, if I put a 1 in there, I get 5. Right? Then 2 in there, I get a 9. If I put, now Farbod, you want to stick with the 19, you want to change it to an 18. Because if I put 19 in there, 4 times 19, guys, is what, 76? Plus 1 would be, what, 77? And the last term should be 73. So it has to be some type of an adjustment there. I understand exactly what you were thinking. But I need to adjust it. Now, does anyone see any way in a break? Love the thinking, love the thinking. I'd like to, for a reason, stick with 1 though, like we did yesterday. And come up with, and I think she's very close to what I need here, another formula. Now, who can come up with a formula that when I replace n by 1, I get 1. I think it was 1. N by 2, I get a 5. Yes?
What about 4n minus 3?
Hang on. 4n subtract 3. I'll accept it if this happens. Replace n by 1, 4 subtract 3, 1. Replace n by 2 in his formula, you get 8 subtract 3, 5. Third term, replace it by 3, 4 times 3 is 12, subtract 3, 9. Farbod. I'm going to now try your 19. Because if this formula is correct, if I put 19 in, that's 4 times 19 is what, 76? Subtract 3, does that give me 73 from my last term? Jonathan, you asked the appropriate question here. That is now expressed like this. You say, where'd that formula come from, Professor? That came from us discussing it, and you're going to say, Friday, I can't discuss. I'm on my own. How am I going to come up with this? I'm looking for a pattern here. We saw a pattern of 4 here involved. There's going to be a 4 in there somewhere. And Ray, she gave me 4n plus 1, and she wanted me to start at 0, which you could. But based on what we did yesterday, I think all those formulas start with a 1, I think, at the base. So I can use those formulas. Jonathan, maybe we should ask Barbad, where did you get 19? How did you know to stop at 19?
Because there was 4n minus 3. So
Hang on. 4n minus 3 that we got. And equal to what?
73.
73. He wants to solve for n. He took the formula, set equal to that last term's value, and you're going to end up with 4n is equal to, guys, what is that, 76? And divided by 4 is at 19, and that's where the 19 came from. Jonathan, you asked for it.
You need another example?
Yeah. Oh, no, hang on, we're not finished with this one. We're not finished with this one yet. Michael, if you had this on the test Friday, just staring at you. And I still remember once I was doing this in a class, and I think we were using calculators then. And the problem came up, and we were trying to have a discussion like we are today, how to come up with the answer. And I kept on hearing the clicking sound. And one of my students had his calculator out. 1 plus 5 plus 9 plus. As you got plus 73. He says, oh, Professor, I got the grandson. What's going to happen if you don't have a calculator? How you going to get that? Caroline, if we accept that this is equivalent to this, I think from yesterday, I can now use formulas. So guys, when we split this thing up, let's reflect back to yesterday, we had a series of formulas. Could I, in that first term, in fact, I'm going to write like this, pull the constant out front, and that's going to leave me this, and just an n, and then subtract, when I separate here, we're going from 1 to 19 of a constant 3. I just split that up. Now, yesterday, anyone tell me what should I apply to find the sum, as it's written right here, from 1 through 19 of n? Just this part right here should be equivalent to, or I can use a formula. Please tell me, was that Mr. Gauss's formula? N times n plus 1 over 2. Just that part. You gotta know your formulas. So in this case, guys, it's 19 times 20 over 2. Do not let me make a mistake on top of the board here. Looks like it's 190. Just for that. Philip, 4 times that will give me, for that first term, to bring it out here, altogether that first term will be 4 times 190. What is that? 36, 760? I did it quickly. Is it? Is it 760? No? Yes? Is it, guys? I did it quickly. Now, am I finished? Now it says subtract from that this one. Now, does anyone recall what a formula from yesterday says to do right quickly to find that sum from 1 through 19 of a constant 3? Yeah, you just multiply these two together. I think it's n times c or c times n. So 19 times 3, right here, guys, is what, 57, I think it is? And then you subtract those two, you should have the answer. Wow, make use of yesterday's work. By the way, the difference is, since we've done all the work here, guys, what difference do I have? 703, I guess? I think I did that quickly. So here, if you wish, if you have time, add them up. Add them up. Nima, if I add them up, all the way down through 73, straightforward adding, we should get this sum. We did it by sigma formulas. Make sense? Okay. Does that help, guys? Okay, I think it does, okay. Yes, Bill?
Yeah, just double checking, how do we get to multiplying 19 by 20? What in the process is it?
I think it was n was 19, so the formula says n times n plus 1 over here, Mr. Gauss's formula. So I put a 19 here, 19 plus 1 is 20.
Alright, makes sense.
Yeah, I finished it up. Oh boy. Jonathan, you asked me the perfect question. So Adrian, if you see just a set of numbers, Randy had it on the test, add these numbers up. 1 plus, in this case, 1 plus 5 plus 9 plus 13 plus 17, all the way down through 73, and all of a sudden you see that, oh my goodness, I can't just directly add all those up. It's going to take all my 3 hours. So it must be some other way. Then I'll have written in my instructions this. I'll say, first, rewrite this using sigma. So I'll sort of guide you through it. I want you to first rewrite it using sigma. And then second part, now since you have it in sigma form, use the summation formulas, split this up, use your formulas, and get the answer. So you're combining all that lesson from yesterday. Making sense? Okay. Now see why you said 73, because that's the last term, right? Why not put 73 up there? Had to be a 19 in this case. Guys, how's that look? Oh, it's very quiet today. I don't know.
Is there any trick to coming up with the formulas?
There you go. There you go. You're saying, Professor, is there some way that you could show me how to create a formula without me keep staring at it and looking for patterns here to come up with a formula? Jonathan, that's going to be hard to do. Your textbook does list some formulas for you that may give you an idea of what to do here. Let me go ahead and do this for you, just in case. Here we go. If I give you a summation, and you see there's a common difference between the terms. Was there a common difference in this one? So let me go ahead and do this, which we were going to do, but I'm going to do it now. It's classified as arithmetic. They use this word. I'll put this on there. I'm going to use the word sequence. You know, this is a summation. If you see there's a constant difference, it's called arithmetic. If so, they give you a standard formula to use to help with that, coming up with that formula that you need. Guys, A subscript n is equal to A1 plus n minus 1 times d. Jonathan, since you asked, if you identify, maybe that might give me a hint of what to put on the test, put an arithmetic. If it's not arithmetic, though, you can't use this. This one is an arithmetic. It's an arithmetic. If it is, there's a standard formula to come up with the formula that you're looking for. It says A1 plus n minus 1 times d. Let's see if it works here. A1 in my case was what, 1? Okay, so it's 1 plus n minus 1. And guys, in this case, that's n minus 1 times the difference. And the difference was what, 4? I think. Is that true? I got 1 here for the first term, that's A1. And I'll leave that n there for a while. D, difference, the difference was 4 on this one. That's what made it arithmetic. There's a common difference. Clean this up, use the distributive property, 4n minus 4. Combine your numbers, you get 4n minus 3. And was that sure enough that formula? Now, Barbot, if you don't see a common difference, Jonathan, if you don't see a common difference, you got issues. That formula will not work. It's not an arithmetic sequence of numbers. If it is, the formula will always tell you what you need for your formula. Make sense? A1 plus n minus 1 times d. I'm throwing all kinds of stuff at you guys today. Yes?
Oh, sorry, I said D. Okay, I was just gonna ask what the thing on the end is in the arithmetic.
D, difference. A common difference. If there's a common difference, from term to term, in this case, Philip, the common difference is 4.
Okay, I just didn't see what it was.
Yeah. If it is, you may apply that formula. Ray, I can't leave you yet. She says, Professor, could I have actually have started at 0? You could. You could start at 0 and manipulate this thing some way, Ray, and got this also to finally give you an answer of 703. You could have done it. If you had started at 0. I like to start at 1 because I think all of them started at 1 yesterday, weren't they, on the handout I gave you with the summation formulas? Didn't they all start at 1 at the base? I think they did. Okay. Wow. And when's the final exam? Friday. Friday. See, Michael shaking his head. Oh, Professor, you're not going to stop? When are we going to say it's over, Professor? We start reviewing. When is it over? Not quite yet. Getting close to it, but I know this is getting a little heavy. We're not going to get too heavy. Yes?
Can you give us an example for the binomial, like theorem or expansion of possible postulates?
Mm-hmm. You mean do the same thing sort of like I did this one?
Yeah.
But maybe say, Professor, can you rewrite it using this?
Can you?
I can.
Yeah.
Okay, we can try one of those, and I'll just express it like that, okay? Absolutely. Here we go. On the side here. Miriam,
Yeah.
maybe, we'll see. Let's try one where you're asking me to expand it out. She says, Professor, it's not fully expanded out. You just write out for me. Show me what it looks like. Okay, guys, that's for a plus b raised to the n. Here we go. Let's try 2x plus y raised to the 10th. We're not going to actually do it. There'll be 11 terms. But, Adrian, what I want is what she wants. She wants, Professor, can you show me what that looks like now using this? Just show me what it looks like. We're not going to actually get the answer. I'm going to rewrite it as a summation with the help of the binomial theorem. Here goes. Miriam, good question. Sigma, and of course we're going to start with 0. I would assume this would, are you going short enough? No, yeah. Is the top number in this case for sure going to be 10? The way it looks. Can I go up to a 10 there for sure? On this one. And she's asked me to put it in this form over here, and the end at the top is the exponent on the outside there, and the exponent was 10, right? Now inside there would be written as n choose j. Guys, n is 10, so it's 10 choose j. That looks like that. Next, oh, here, good question. Now it says a raised to the n minus j. A in my case is 2x. Raised to the 10 subtract j. That is this one. And next it says what? B raised to the j. What's acting as my b here in this binomial? I see a y. So it's y raised to the j. Miriam, excellent, excellent, excellent. This and this are saying the same thing.
Okay, so on the test it'd be like write one of those.
Just write one out. I'm not going to ask you to expand it out.
Okay.
I'll just ask you probably to use the binomial theorem and show me what it looks like in this form.
Okay.
And then just stop. Is that what you wanted there? Yeah. That's what it looks. Okay. Now, I gotta watch my time here. We're going to review some, start reviewing the test. You'll say, Professor, how much more of this is what we're going to do? Wait a minute. After today, Professor, can you say we're finished with the course? Or do you have more tomorrow to do? Tomorrow's Wednesday, right? Maybe almost finished today. guys, I'm gonna erase this, look at this now. Make sure Miriam asks the appropriate question, make sure you understand this can be written like this. It's called binomial theorem. Now, Miriam, I could ask you maybe just write out the first couple of terms from this, just to see if you do understand what the first couple of terms would look like, not actually expand them out, just write them out for me.
Like J equals 0.
Exactly, like this. The first term would be 10 choose what, 0? 2x raised to the what? 10. Y raised to the what? 0. That's the first term. Second term, I'll write one more out, would look like what? 10 choose 1. 2x raised to how much? 9th. And y raised to what? First. And then you can write all those out for me. I'll just ask you to write 2 or 3 of them out for me. I will not ask you to expand them out. Just write a few out and leave them in that form, just make sure you understand what's going on here. Binomial theorem. He said, Professor, when I get to calculus, Arena, Mr. Park, did you guys ever use binomial theorem? You're in math 8, he's in math 13 or whatever it is, 15? Did you guys ever use binomial theorem?
I remember I used that 15 a lot.
Oh, you did?
Yeah, and yeah, we use it a lot in 15.
In 15?
Yeah.
Nowhere yet in your 7 or 8?
Yeah.
So I guess you'll just have to wait, guys. If that's true, your instructor in Math 7 may decide to do this. Mr. Park says Math 15, do you get there? Math 15? He says definitely you need it there. So think me, think Ramsey when you finally get to 15. You say, I finally see now use of the binomial theorem. Okay? But they have this as one part of the Math 2 syllabus that we should be doing. Guys, I just want to make sure you see what's going on here. Now, I've got a nice little conclusion here on this. Here we go. On the side here, we got an answer of 703. These numbers will sum up to 703 with the help of these sigma and sigma formulas, summation formulas. I have now, look at this. Okay. Okay, over here. 1 plus 5 plus 9. I don't want to scare anyone. So forth and so on. Up to 4n subtract 3. Something like I saw over there is equal to this. You're talking about a nice connection. Beautiful connection. See that problem there? I gotta switch back to that problem there. This on the left-hand side agrees with what we finally came up with. Jonathan, you were asking, Professor, it's hard for me to come up with the formula. And that's where it gives me insight here. Well, suppose the formula's given. There it is. It's given to you. I use a 4n minus 3. I see a 4n minus 3 given to me. Now, what's that formula on the left-hand side give me? It gives me any specific term I wish to find on the left. It's only for the left. So if I want to value the 10th term on the left-hand side, put a 10 in there. 4 times 10 is what, 40? 40 subtract 3 is what, 37? So you're guaranteed the 10th term on the left-hand side, if I should write out to the 10th term, has a value of 37. Can someone tell me? Oh, what a beautiful connection. What's this tell me? What's the other side tell me? And we sort of talked about this yesterday. The left-hand side is telling me exactly what we had here. And that was given to me on this one. Just give me a specific term in that, they call it a series, a summation. But the right-hand side is telling me what, which is going to be such a beautiful connection to what we just did. Adrian, what's that right-hand side telling me?
It's the sum of everything up until 4n minus.
It's telling me what the sum is. Now, on this particular problem here, I was asking you to sum up through what, 19? I think it was, wasn't it? Jonathan, if I gave this to you, written like this, he's telling me, Professor, it looks so much like this problem over here, but you've already given me so much information, just plug a 19 in here. 19 times 2 times 19, subtract 1, that's 19, subtract inside there, guys, what's 37? I think. Let's do that quickly. Mr. Park, what's 19 times 37? I did it real quickly.
703. Yeah.
Caroline, would it help if on the exam, because you're going to have so much more to do on the exam rather than just all this, would it help, and Jonathan's saying I'm sure it would help, would it help if you knew a formula written right there in front of you that would give it to you and you don't have to go through this business? Isn't that nice? We went through sigmas. Now all of a sudden I give you the formula. You say, Professor, where that formula came from? I'll give it to you. Where'd it come from? I'll give you the formula. Adrian, did it work out? Did you give me the same sum, 703, as we got from the previous? What a connection. Now here's the way I'm gonna close down. And we'll take a break here soon and start some review, because I'm concerned about the review in here. Guys, here goes. Watch carefully. This is the last one you'll see me do. Did I do an induction proof yesterday? Something called math induction. Did I actually do a proof, maybe it's 3 steps proof of some sort yesterday in class called math induction, like a proof? I want to prove